Welcome to lesson 21 of this Arduino C++ course, and today we're going to be looking at the CD4021BE shift register. Now the first question is, what is a shift register and why would you need one? So moving straight over to the workbench, as you can see over here I have the beginnings of a control panel. I've been sort of making some prototypes. And this control panel is going to need over 70 pins to take all of the inputs and the outputs for the LEDs and the various buttons. Now, if we look at our Arduino Uno, what have we got here? 13 pins, of which realistically we can use 11 of the digital pins, and we could squeeze in the analog pins. If we move over here to the Arduino Mega, here we can get up to, 53 digital pins? But that's not going to be enough for what I need. So the shift register, which is this little chip here, is a way of adding more inputs to the Arduino. And on this sort of bird's nest of a breadboard, I've actually got 4 of these chips in here, and we're going to add today 32 inputs. So if you click on the link below the video, you can go over to the lessons page on the Digital Town site, and this will bring you to this page here. So this is the resource page for today's lesson. We're going to have 3 sketches. Obviously just download the code from here. There is also a link to the Arduino tutorials page, which will show you a little bit more about shift registers if you want to use it. And then we have the circuit diagram for a single chip, and then an idea of how you would use multiple chips, how the shift register works, and the pin out. So let's have a quick look at how it works first by looking at this diagram. So the way that the shift register works is it has 8 pins that are used as input. So you can attach a switch or a button just as you would directly to the Arduino, and it basically receives a high or a low. One thing to remember, if you are using switches or buttons, you will still need a pull-up or a pull down resistor. We then have 3 pins. The first one is called the latch pin, and this, when it is triggered, tells the chip that we are ready to start receiving data. We then have a data pin that starts to, if you like, receive the data by giving itself a series of high or low values. And then we have a clock pin that gets ready for the next sort of bit or byte as appropriate. So the way this works, we're going to get a series of zeros or ones depending on which of these registers is turned on or off. Now, one unfortunate thing about these chips, unlike the diagram that has a very nice sort of line of chips. It would have been nice if it had been 0, 1, 2, 3 going up to 7, but as you can see, the pin that gives the first value is down here, bottom left. Then we go 1, 2, 3, 4, 5, 6, 7. Why is it in that order? That's beyond me. I'm sure it's something to do with the way that the circuit is made on the actual chip. Then we have a ground and a VCC. Now, if you're using the Arduino Uno or Mega, VCC needs to be 5 volts. If you're using something like a ESP32 or an Arduino Duo, a 3.3 volt board, then the VCC needs to be 3.3 volts. We then have 3 connections to the Arduino, a data connection, the clock, and the latch. But there is also another connection here if we want to daisy chain more of these chips. So looking at the simplest of examples, here we have our chip. I've put one example button in, and you'll notice on my breadboard I haven't actually used buttons as such. I've just got some headers so that I can just touch them with a wire. So I've got some pull down resistors that go from the pin to ground, and of course when the button is pressed then the pin goes high. We then have our connections going off to the different pins on the Arduino. We've got our data and then our latch pin and our, hang on, I've forgotten the name of it. It is the clock pin. So these are the connections that we have here. Now this is for a single chip. If we want to have multiple chips, the data pin, this one here, daisy chains from this pin over here, comes out and then goes to the input of the next chip, while the clock and the latch pins just continue across. Now if you want to add more chips, and I haven't added more on the diagram because it takes too long to draw the thing out, it's literally a case of repeating this over here, and once again you would connect the data from this pin coming down to the next pin just as it works through here, and again you just daisy chain off the latch pin and the clock pin. So the circuit itself is a fairly simple circuit. The only problem you'll see is on the breadboard, when you're trying to put all of these components in, it can get a little bit messy, but the circuitry itself is very, very simple. And the great thing is, because you can just keep adding these chips, every chip that you add gives you another 8 inputs. Now, as I've said, I have got a switch connected here, and in my example I'm going to be using the equivalent of a switch. These could be any kind of sensor. It could be an IR sensor or something like that, something just giving a high or a low output, and they will work equally well with these chips. Now you might wonder, well, how much are these chips going to cost me? Well, I bought mine off AliExpress. I've just bought another 10 for this project, and it cost me £1.70. So they are very, very cheap, you know, a very, very cheap way to add extra pins to your project. And no matter what board you use, you will always run out of pins eventually. So today's lesson is going to focus on how we get these values out and into our Arduino, and then we're going to work through 3 sketches, with the final sketch showing how you would use these various inputs to control outputs from the same Arduino. So let's get started with our first sketch, and our first sketch is version 3. It's version 3, 4 and 5 today. That's a historical thing for me, because when I first started to work with these chips, I had an issue many, many years ago, and thanks to someone called Runaway Pancake, they gave me a little bit of a heads up on the bug that I was finding. Right, let's get started. So something that may be new to some of you is something called a definition. Now, usually we would use a variable. We define the variable type, integer or unsigned long or a byte, whatever it would be. We give it a name, and then we give it a value, or leave it like these ones with the default value, which will be 0. A definition works in a different way. A definition cannot be changed because it's the equivalent of a search and replace in a word processor. So wherever this is written, which in this case is in my array, this word will be replaced by this value 1. So if I have a value of 1, I'm going to create an array with 1 element, whereas if I then change this to a 4, then this will become a 4-element array. Now, if you get a bit stuck on how arrays work, they were covered back in lesson 9, I think it was. And the thing with an array is if we have this integer here, it stores a single value of 8. If I have a 4-element array, this array can store 4 separate values. So that is the main difference between an array and a single variable. Now the good news is that by the time we've got to sketch 5, I will have written you some code that will help you to use all of the outputs without you sort of having to have an in-depth knowledge of how arrays work. Right, now we've got the 3 pins that are connected to the CD4021 chip, and that's going to be 8 for the latch pin, 7 for the clock pin, and 9 for the data pin. I've then got a variable micro delay, and this is something that has to happen within the code. Now it is a micro delay, and I'll explain a little bit more about that later. I'm then using current millis as always for the timing, and I'm going to read these chips every 20 milliseconds. Now coming down to the setup, one oddity here. You'll notice the serial monitor is running at 115200, so make sure that down here you change the baud rate, otherwise you're going to get gobbledygook coming out in your serial monitor. Now the reason for setting this higher than normal is that it's going to be passing a lot of data, and if I left it at 9600 it would actually cause quite a bottleneck. So next in the setup, it's just simply a case of declaring the pin modes, and the data pin is going to be an input. That's the pin that we're receiving information from, and the latch pin and the clock pin are outputs because they send commands to the chip. So now we come down to the main loop. I've got 2 variables that I've declared, and these are just there as counters in the code. Now, one of the things, because they are declared within the loop, every time the loop goes round, they will be reset to 0. Whereas if you declare a variable outside, if you like, up here in the header, then if I give the variable a value, that value is readable within any function. Right, as normal, we've got current millis equals millis at the beginning of the loop, and then the usual way of reading the data. Now, at the moment, I'm going to read these pins every 20 milliseconds. Let's just change that value there. I think reading it every 20 milliseconds is quite fast enough to catch any touches on the buttons. I'm too old to move any faster than that. So let's now have a look at how the code actually works. So I'm going to go through this, but don't panic if you don't understand it, because you will still be able to use the code at the end. Now, the first thing that we're going to do is set the latch pin correctly. Now, what we're basically doing here is before the data can start to flow from the single chip or multiple chips, if you like, we need to open the valve to let the flow begin, and that's what we do here. So we're going to call a function called latch4021, and I'm going to give it the latch pin number. Now, as we go down at the bottom, there is a function here, and you will see that what it does is it sets the latch pin high. Then we have this delay microseconds. Now, usually when you see delay, it will be written like that with sort of, let's put 1000 in. So that would give us a delay of 1 second. But microseconds, well, to have a delay in microseconds, we would actually have to add another 3 zeros. Now, anyone who knows me and my tutorials knows that I hate delay in my code. It blocks other code, but thankfully we can get away with a delay here of, what are we using at the moment, 30 microseconds. So that is what's that? That's about 0.000003 of a second. It is a minute amount of time, and it's just enough to allow the chip to record that the pin went high and then it goes low. If you don't have this tiny little delay in here, if you just go high and then immediately low, sometimes the chip doesn't register that it has received the instruction. So this is what this delay is about. I'll be honest, in some of my sketches I've managed to reduce this down to sort of 10 and even 5, but I'm leaving it at 30 in here just to be safe. So that's all this does. This little function basically turns the tap on. So now we've turned the tap on, what we now need to do is start pumping, if you like, our data through. And this is where this little section comes in. So we're going to work through the number of chips. Now, obviously, if this was 4 chips, it'll go round this for loop 4 times. If it's set to 1, it's only going to go round once. If you'd added 10 chips, it's going to go round 10 times. And what it does is it fills this array with a set of bytes of data, and those bytes are created by this function. Now, for those of you who struggle with your bits and bytes, let's just get the calculator up. There are 8 bits in a byte, and they're made up of a series of ones and zeros. So let's create ourselves a series of ones and zeros, and as you can see, this comes to a value, a decimal value of 170, a hexadecimal of AA. But what it is basically, as you can see, it is a set of ones and zeros, and because we can actually interrogate these individual ones and zeros, that allows us to work out the, if you like, the on or off state of every single pin. So looking at this function, which again is down here, so it's getting the data pin and the clock pin, and what it does is it is working through the 8 pins, and what it's doing is it's reading the pin. So it's saying, right, what is the current value of the pin? Is it high or is it low? If it's high, we're going to bit write the value into the byte of data. If I go back to my calculator, so what we're going to do here is, if we have got a 1, we're going to read it as a 1 and enter it into the byte. If we've got a 0, we're going to add it as a 0. And it's basically going to build up a set of zeros and ones. And then what it does is, at the end, it does this weird sort of clock pin low, delay, clock pin high. And that means now that it's said, okay, we've read the first value, reset. Now I want the second value, and it works through, and eventually this variable, this byte of data, will consist of all the 0 and 1 states of the various registers on the chip. So once we have all that data, then all I'm going to do is I'm going to serial print out the binary value of the chips that are connected. So that's all the theoretical side. Let's see this thing in practice, and we're going to start with a single chip. So moving back to the webcam, the way that I've got this set up is just here. It's quite difficult to see. There are a set of little headers that I've set up, and these will allow me to touch them with this wire here, and that will be the equivalent of pressing a button. So let's look at this working. So as you can see in the serial monitor, we have a value of 0. Now, if I touch the first pin, I get a value of 1. If I touch the second pin, I get a value of 10. Next one is 100, 1000, and on we go right up to the end pin, because that is the pin that I am touching. Now what I'm going to do is just stick that one in the 1. I'm now going to bring out another connector, plug it in, and you can see now that as I touch other pins, we now have multiple values coming up on the output. So as you can see, we can now record exactly which buttons are being pressed. Now what I'm going to do is quickly change this to 4, and we just upload that. Now you can see the serial monitor has changed. I've got chip 0, chip 1, chip 2, and chip 3. So you can see that chip 1 has got a value of 1. In fact, what we'll do is we'll move that connector to a different value just to show that that's working. And then we'll plug this one in here. Let's bring some more in. And finally, we'll put this last one in and just start to touch it against the various connectors. So as you can see, we can have multiple buttons being pressed at the same time on multiple chips, and we're able to read those constantly. So now we have these values coming out of the chips, and obviously if I added more chips, this would just expand across, but these aren't exactly the easiest to process if we would now want to, if you like, turn on an LED or move a servo or something with these values. So what we're going to do now is put these values in an easier format to use. So here we are with Sketch version 4, and the big change is this line here. So this time I'm setting up another array. This is a slightly different array in that before we were storing the number of bytes, if you like, 1 byte per chip. What I really want though is 1 byte per pin. So that means we've got the number of chips multiplied by 8, and that will give me a position in the array for every single pin combined from all of the chips. Now going down through the rest of it, basically it all runs the same until we get to the main loop, and this time I've got a button count and a pin count variable. Now as before, we're going to every what are we reading this one? This is going to read every 100 milliseconds this time. And once again, it's going to go through that same bit of code, and it's going to open the tap and then start working through the chips, and that will then get all of our data into this array. That those are going to be the 4 bytes in my case of data. But then I've got this for loop here where I'm going to work through the number of chips, and then I'm going to work through each pin, each if you like, bit in the byte. I'm going to work through them all, and I'm going to put that value into my buttons array. Every time I do that, I'm going to increase the value by 1, and that means that eventually, in my case, I'm going to finish up with 32 values within this array. Now what I've then decided to do is just serial print it out so that you can see what I'm actually going to produce. So if you think it's a little bit confusing, hopefully when you see the output, you'll start to understand what's going on. So if you remember the old output, it looks like this. Now the output, as you can see, looks slightly different, and we can see that we've got a 1 here, a 1, a 1, and a 1. Now if I bring the camera back in and I start to play around with the contacts, you can see as I move across, I'm getting the different variables. So I've damaged a wire there. And once again, I can touch the other contacts here to add extra values in. Now, the advantage of this, of course, is that it is much easier to deal with this array like this, because I can now treat this as buttons sort of 0 to 32 and process them accordingly, as you'll see in the next sketch. Because when we're working with the Arduino, what we really don't want is a bunch of zeros and ones in the serial monitor. What we would tend to be doing is, if these are represented by buttons or switches being moved, then what we actually want to do is then do some output work based on what has happened with the inputs. So sketch 5, the big change is here in the My Buttons array. Now you'll notice that this time it's got a 2 after it, because it's going to be a 2-dimensional array. So that means we're going to have the number of chips times 8. So in my case, that's going to be a value of 32. And then each of those pins is going to have 2 values. One is going to be the value of the pin as it's just been read. The other value will be its previous value when it was last read, and you'll see why in a moment. Now the rest of it, all of this is identical. The setup remains the same, and most of the loop remains the same. The big change comes when if you like, I've got all my data into my CD4021 byte array. The change then comes in how I then deal with that data, getting it into that one big array for all 32 buttons in my case. So if I bring in the previous sketch and just put the two sketches sort of side by side, just make sure I've got those at the right position. There we are. So in the previous sketch, we put the value into the array. The difference is here, we're going to put it into element 0. So this is going to be the first element in the array. So the first element in the array will continue to have exactly the same values as the previous sketch. The difference is then that when I start to process these, I'm going to go through a for loop, and what I'm going to check is the value of the button at the moment the same value or different to the value that was previously read on that button? Because if the value has changed, that means that the button has been pressed, if you like, something's been turned on or turned off. Now, if that has happened and they are different, the first thing I then do is update the second value to the first value. So that means that then if the button changes again, it will read it as different again. But now that I know that this particular button has been changed or pressed, then I'm going to process the button. And this is where you would, if you like, put in your activation code. So what I've done is put some sample code in, and I'm going to use pin 0 on chip 0, which in my case is bottom left of my setup. what I'm going to do then is pretend that that is a latching switch. Now, a latching switch is a bit like your normal light switch, where the lights are on or they are off. You press the switch and it stays in the new position. It's latched in that position. So those sort of switches, on or off. So what we're going to do is we're going to say, right, if the switch is greater than 0, if you like, I'm getting a 1, then I'm going to say that the pin is high. I'm going to serial print that out. But some sample code, if you were going to turn something on, this is where you'd put your digital write to my pin, and that would turn on your LED, transistor, MOSFET, or some kind of module, whatever your project would be. If, however, the switch has suddenly changed to a low, then we would set the pin low, and I'm going to serial print out that as a low. Now, what I've done for the next chip, which is 8, because obviously we start at 0, so 8 is bottom left of the second chip. This time I'm going to move a servo theoretically. So this time again, we're going to use the latching switch example. This time though, if it's gone high, then we would do a servo write, and we're going to move it to a position of 25. And I should change that there, and I should put that to 125. So if you like, the servo will be moved in one direction when it's gone high. It would be moved in the other direction if the pin has gone low. So that's how the code would work if it was a latching switch. Now, when you come to momentary switches, you may only want to do something when the button is pressed, but then get another button to process the other direction. Let me just give you a visual example of that. So if we look at my control panel here, the way this will work, these little dots, there'll be an LED in there. These bigger dots, there will be an item that I touch with a probe. Now, the way this will work is if I want the track to go in this direction, I will touch this item here. If I want the track to go in the other direction, I will touch this one here. So I don't double touch this one. It's one press for one direction, one press for the other direction. So it's one press, one button for one action, a second button for a different action. So in my case, I'm going to use on chip 2 pins 6 and 7. Those are the two pins on the far right of the chip. And what I'm going to do is, if the one pin is pressed, it's going to serial print out this information. Again, press chip pin 23, and it's going to send out this other information. And then for the final chip, I just put some code in here as if it's going to do a digital write to set a pin high and to set a pin low. Now, obviously, in my setup with this control panel I'm building, it would actually set one pin high and one pin low, and over here another pin low and another pin high, because one LED is going to turn on and one LED is going to turn off. In fact, on the control panel, it may even send another instruction because it may move a servo as well. However, for now, let's just deal with getting the inputs from the switches. So let's run this up and see it working. So to make life a little bit easier for myself, I have plugged in a connector on the first pin and this second chip. These are going to act as those latching switches. So if I now disconnect this one here, you watch the serial monitor, you can see that as I've unpinned it, chip 0 has gone low. Put it back in, that has now gone high. And again, we have this one working over here in the same way. So these would do the equivalent. What we've just done there is we have serial printed out this, but if I'd had this digital write in there, obviously I would have turned something on or off at the same time. Now we're going to come down to pins 22 and 23, and that is these two pins here. So if I touch the end one, you can see that I get the one reading, moving it across between the two. You can see that it is swapping between the readings. Right, finally we're going to go onto that final chip, and again it's the same thing going on there, and as you can see chip 3 has been switching between pins 6 and 7, which again, if we'd had the code in, we would have been able to digital write a pin high or low. So from that, as you can see, we have a very simple way of just using one long for loop with a switch statement within it, and that now allows us to process all of those pins one by one and do the appropriate action, the appropriate output, depending on what has changed with the input. So I'm going to finish the video there for now, because what I'm going to do in the next video is obviously I need a lot of output pins, so we're going to look at a different type of shift register so that we can have multiple outputs. So we'll deal with that in the next video and then start to put the two together. So I hope that's been useful to you, and as you can see, using these chips is an extremely useful and cheap way of adding almost endless inputs to your Arduino or ESP32, whichever board you're using. And what we'll then do is in the next one, as I've said, I will start to look at adding extra outputs. Hope that's been useful, and if it has, please click the like and subscribe, because it really does help the channel. Thanks for watching, and I'll see you in the next video. Bye for now.